Hello, hello. Can you hear me? Can you see the stream? Hello? Okay, so hello everyone and welcome to this episode of the Tech Talk Sing Song. My name is Claudio and I'm going to talk to you about the AMP technology from Google. AMP stands for Accelerated Mobile Pages, and it's a project whose purpose is to improve the current scenario of mobile web pages, oriented in a way that it improves the user experience and the advertising scenario. So before introducing the current scenario, let's see what are the promises of this project. This project promises of make page loading to be basically instant, to improve user experience so that users are more likely to engage with the content. And this implies higher conversion rates because we know that when web pages load slowly, especially on mobile devices, user experience is not very good, users are frustrated, and often they leave the page before they can get to the content. This of course is bad for users because they get frustrated. This is bad for publishers because they do not have a better way to monetize the website. And of course this is also bad for advertisers because what they are advertising is uh, does not convert. And this was the current scenario. So we know that for each extra second of wait, approximately the 12% of users leave for each second. This means that after 3 or 4 seconds, around the half of the user base will leave the website. So the chances of conversions will drop to the almost 50%. And what is bad that is that this frustration of the users will bring them to install ad blockers or even browsers that include an ad blockers, for example the Brave browser. And of course they will lose trust and confidence with the website. So let's see in what AMP is about. What are the components, the core components that make up this technology, and how they are used to fulfill the promises we open this tech talk with. Basically, there are three core components. There is of course, the HTML part, which is basically the regular HTML with a few restrictions and with a few AMP specific properties. There is a JavaScript library which improves the rendering times and the drawing times of the DOM elements. And also there is the possibility of serving AMP documents with special cache distributed by Google, which basically delivers content that is ready to, that has been validated with the AMP validator. So let's see in more technical detail how these three components work together. We have a set of allowed HTML tags, and which are the for example H1, H2, 3, 4 and so on for headings, paragraphs, buttons, SVG components and so on. These tags are allowed because they do not affect the page speed, loading times and so on. So they are allowed without restrictions. Instead, there are a few tags that are absolutely prohibited. For example, frame, iframe, embed, base, and other. This because, for example, let's take as an example the iframe tag. When you load an iframe, when you load content into an iframe, it's unpredictable the waiting time of the content you are going to load, and this can block the rendering of the hosting page. So this is a huge problem, and that's why the iframe item is prohibited. But AMP replaces some prohibited tags with other optimized tags. For example, we talked about the iframe. AMP provides an alternative to the iframe, which is AMP iframe, which is basically a wrapper of the regular iframe content, iframe tag, sorry, but it optimizes the content of the page which is loaded within the iframe. For example, by replacing each call to document.write method, which is known to be a synchronous method that makes the loading very slow. So this specific tag will take care of optimizing the loading of the web page that is going to be included in the hosting web page. In a similar way, the AMP image tag works. Basically, this tag includes some settings, properties and attributes that optimize the loading time and the rendering of an image, and in a similar way the AMP video tag works. Additionally, there are brand new tags which are provided by AMP itself, which they are community driven, and with this I mean that the community can contribute and create new AMP tags. For example, and I'm mentioning only a few of these. There is the AMP ad tag, which is optimized to host an advertising, or AMP lightbox for image galleries, or AMP Reddit, or Twitter, Facebook, and other tens of components to include third-party content in your page in a way that it will not block the rendering or make the your page to load very slowly, because we know that what makes a page to load slowly is poorly written JavaScript. For example, I mentioned before the call to document.write, just to mention one, but there are plenty of examples. Loading third-party content, this is known to be a bad practice, because the content, the weight of the content you're going to load is unpredictable. So you don't know how long will it take to load this third-party content. And of course, your page is affected by those slow loading times. One thing that I did not mention so far is the CSS. With AMP, there is no concept of CSS external file. Because the CSS is another point where which is known to slow down the loading of the page, because loading a style sheet is a synchronous operation that can block the rendering. And that's why in AMP the amount of CSS used is very minimal, and it's inline. There is no external file included in the web page. All the style definitions are included in the inline. And this happens to minimize the amount of data loaded. So let's see very quickly a real-life example of a page powered by AMP. This is the GitHub repository of the AIM project, which has plenty of examples you can have a look at. So let's see, for example, this page. As you can see, the definition of AMP is done by this lightning character. This character can be replaced with the literal AMP in case you are not comfortable with writing Unicode characters. As I said before, we only include the fonts, the CSS of the fonts, and the style is defined inline. So we have a very minimal definition for the body and some fallback definitions and a spacer. This element, the script tag, loads the AMP library, as I said before, which is one of the three core components of AMP. And here you see the AMP YouTube tag being used. Basically, this component replaces the regular way you have to embed YouTube videos in your web page. So if you are going to see the contents of this YouTube tag, we will see that it wraps the original content, so the original YouTube snippet, and it optimizes it. So as I said before, there are allowed tags. In this case, it's H3 button, H2. These tags do not affect the loading time of the pages, so you are you can feel free to use it without restrictions. Another interesting example is the AMP GIST tag. GIST are basically snippets of text. This is a service provided by GitHub. These GISTs are very popular for example, programming blogs or programming websites or generic sites where you need to embed some content from GitHub as GIST. So as for other components, the AMP GIST internally is optimized to reduce the loading time of the GitHub GIST to serve immediately the content. So if you are familiar with AngularJS or Polymer or other modern web framework, you might have guessed that these custom tags, for example AmpGist, are called web components. Web components have four specific features, which are the ability of declaring a custom name for the element, in this case amp gist, the ability of using shadow DOM, and using HTML imports, which means importing snippets of HTML in another HTML document, and using templates. Among these properties, these features, the most important is the shadow DOM. And it's important in a way that AMP relies on this feature, because the shadow DOM means that the content is loaded into a separate DOM, which is separate from the context of the web page. This means that if I do a change, a style change on a page within a shadow DOM, the browser will not have to reload and recalculate and redraw elements for the whole page, but it will only work against that very little shadow DOM content. And this is one of the key features of AMP, one of the things AMP relies on to provide faster performances and faster waiting times. This is very important to understand. And the last tag I want to show you is the AMP add. Basically, this tag is optimized to show advertisings. For example, in this case, you use this tag by specifying the sites, name of the publisher, and the source. And as you can see, most of AMP tags specify width and height. This because it forces the browser to optimize. It forces the component to optimize the content. Because if we do not specify width and height, the content will adapt to the embedding content, and this causes unpredictable waiting times and drawing times on the browser. So it's a very good practice to specify width and height. Okay, so this was an overview of the AMP tags and how to use it in an actual web page. Now let's see a real-life scenario when two websites are compared. One website uses AMP, and one website does not use AMP. Specifically, I meant one page uses AMP and one page does not use AMP. For example, this is an article from the same website, which is TechCrunch. On the left of the screen, you see the regular mobile page of TechCrunch. On the right, you see the same article served by the Google AMP cache. So this is served by the domain of this web page is google.it in my case, because this is served by the Google AMP content delivery network. So let's see real quick what are the differences in loading the regular web page and the accelerated mobile page. I will do a hard reload of this page, of the regular page, and you can see that so far more than 1 megabyte of data has been loaded. Not sure if you can see the so I am zooming just to show you the amount of data which has been transferred, which is 4.7 megabytes just to load one simple post about NVIDIA. So what we get here is 4.7 megabytes and almost 260 requests, which are a lot. So let's see instead what happens when we load an AMP page with the same content. See? It's only been transferred around 400 kilobytes, which is 10 times less than the regular mobile page. Also, only 51 requests have been performed, again versus the 260. So you imagine being on an actual mobile phone, maybe with a slow internet connection. Loading 4.7 megabytes can be a big deal. Also, as you can see, it took almost 6 seconds to load the content. Instead, with the new AMP page, it only took 2 seconds to load. So if we go back to what we opened this tech talk with, and we consider that for each extra second of wait we lose the 12% of users, we immediately see that we lost a lot of users when loading the regular TechCrunch web page. Also, when you load the regular web page, now I'm taking TechCrunch as an example, but there are thousands of websites like this. You get a lot of content you might not be interested in. For example, this advertiser here, this promoted content, or other things we might not be interested in. Instead, with the AMP page, we only get the content. So this is, from a user point of view, this is convenient. Also, we still get an advertising here, but it's not deceptive, not intrusive, not basically it doesn't want me to install an ad blocker, because this is okay. I'm fine with this kind of advertising. This is basically the whole point of AMP. The current scenario is that there is no real winner, because users have a bad experience. Publishers in their turn have bad experiences, because if users install ad blockers and extensions, their website will stop to monetize. And advertisers are not happy as well, because they are not selling. So this was basically a very quickly overview of the AMP project. On the website you can find of course, the documentation and other resources. For example, which is very important, a tool to validate AMP documents. So from a developer point of view, this is another good thing of using AMP, is that you don't have to um, implement too many variations of your code for example, for different browsers, because under the hood, AMP elements are optimized for all the major browsers. So this is a very important point for developer point of view, since we only talked about a user, publisher, and advertiser's point of view. So I'm done with the presentation. For any questions, I am on the Slack channel as usual. Okay, I resumed the streaming because I missed answer questions in the Slack channel. So Sergey is asking, how does AMP differ from classic lightweight web pages? Can I just inject CSS into HTML and don't let lots of ads and simplify design on my sites and don't use AMP? Yes, that is an option. Basically, the thing is that optimizing a website. Sorry, let's do this other way. I will answer the second question, which answers your first question as well. What considerations should I make before converting all my sites to AMP, and are there any downsides, and what types of sites are not suitable for AMP? So this is a very good point. There are sites that might not be suitable for AMP. For example, if you need, if you don't, if you only need to serve content, for example, reading content, so a blog or an image gallery, then you probably do not need a sophisticated design, okay, but you can focus on content. In that case, AMP is very, very suitable, because AMP is focused on content. Also, on mobile websites, you only have 4 or 5 inches of space in the screen. So maybe too much sophisticated designs are not suitable for mobile sites altogether. So, but if you need something more complex, not on the design end, but on the interaction end. For example, you need a mobile web application. In that case, AMP might not be suitable, because for a web application, first of all, you need a lot of JavaScript and you need a lot of CSS. And so the content itself is not really the most important thing, how you to organize content, but how you interact with the application. So for web application, AMP is not suitable. For blogs or news websites and other websites whose purpose is serving content to users, then you can go with AMP. And you can optimize. There is not really a huge difference between a very well optimized website and a website served with AMP, with the only big exception that you can take advantage of Google AMP Cache for AMP project, for AMP documents, which is something you cannot do with the regular caching networks that exist at the moment. Personally, I never seen a website load faster than AMP documents. Are there any other questions?